Hello, welcome to the insight of the research proposal for experiment of Boolean strain profile characterization in Koji downhole condition. This is a part of assessment GSOE9011 engineering research skills. My name is Kazushi Nishimoto. I work for Team 39. Our engineering research challenge is maximizing hydrocarbon reserves. We focus on the reservoir strain application in oil and gas. The benefits are not limited to hydraulic frac monitoring, compressibility analysis and estimation, carbon dioxide capture and storage capacity analysis, new energy projects such as the methane hydrate. Two typical solutions for downhole strain application can be realized by fiber optics technology. One is fiber bracketing, and second one is a Boolean strain sensing. Fiber bracketing is the commercial technology for oil and gas used for hydraulic monitoring. The fiber cable length for the strain sensing is limited up to a couple of 100 meters. The fiber cable is expensive because it requires a special manufacturing process to make a strip of refractive indexes inside of the glass material of fiber core. The depth will be selective because sensing part of the fiber have to be predefined before the installation to an oil well. On the other hand, the Boolean strain sensing is the commercial technology for civil engineering, and pile, tunnel, and pale for heavy structure bridge deformation monitoring is the typical application. The fiber cable length, unlike fiber bracketing, is almost unlimited. It can be a few tens of kilometers long. The conventional fiber cable can be used so that manufacturing cost will be cheap. The entire well trajectory can be covered. So our research question comes from Boolean sensing. What is the performance for Boolean strain sensing in a downhole environment? The objective for our research project to characterize the performance of downhole strain monitoring by Boolean. Our specimen is specially prepared for this experiment. It consists of dual casing, cemented in annulus. An array of strain gauges is run through the specimen, and fiber cables make a loop at the end and top of the specimen and connect it to a BOTDA. The specially manufactured hook will be attached only to the inner casing, and during the experiment, only inner casing will compressed and pulled. Outer casing will be leave unstressed. The distributed strain profile inside the cement will be monitored. The entire specimen, which is the 2-meter long, will be stored in the oven like this in the picture, and temperature will be monitored and controlled during the experiment. Accelerated aging technology applies to the fiber cable. The fiber cable to be aged as 5 years used in the typical oil wells under certain conditions. The data analysis, we compare the Boolean strain sensing and the strain gauges measurement to the analytical solutions we computed prior to the experiment. Conclusions. The Boolean can be the only solution to monitor strain profile over the entire trajectory. The distributed strain profile in such long distance may reveal productivity of hidden reservoir in addition to already proven hydrocarbon reserve. The experiment proposed has never been done in the past. The expectation of the experiment is understand the reliability, but also to identify technical limitations to realize the Boolean strain sensing used in downhole. If limiting factor is identified, the corrective action may be suggested in relation to the next research project. This is the end of my presentation. Thank you for listening.